Hello all, I am Manohari, working as Assistant Professor in SNS College of Technology from ECE department. In today's class video, we are going to understand the PIC16F877A microcontroller block diagram in very simple way. If you are studying a microcontroller, this is one of the most important topic for exams and interviews. By the end of this video, you will clearly understand the internal architecture of PIC16F877A. Now let us talk about the PIC16F877A. It's a 8-bit RISC microcontroller based on a hardware architecture. It operates 20 MHz, contains 8K words of flash memory. It also includes 268 bytes of data memory, RAM, and 256 bytes of EEPROM. One major advantage is that it have a 33 I/O pins. It make it suitable for a embedded system application. Next, move on to hardware architecture. What is meant by hardware architecture? In this architecture, program memory and data memory are separate. Because of this, microcontroller can fetch instruction and access the data simultaneously. This improves execution speed. It also supports pipelining, where one instruction is executed while the next one is fetched. This is why PIC microcontroller are faster than traditional. Next, move on to block diagram. At the center, we have a CPU core. Around it, we have a memory unit, I/O port, timer, communication modules, peripherals like a ADC and PWM. If you are thinking about it, this is a small mini computer inside a single chip. Moving on to CPU. CPU core consists of a 8-bit ALU. It performs arithmetic and logical operation. It contains a working register. It also acts like an accumulator. Status register stores flags like a 0, carry, and digit carry. The program controls the instruction flow. It gives the sequence of flow, and 8-level stack is used for subroutines and interrupt. Moving on to program counter. Program counter is a 13-bit wide. It stores the address of the next instruction to be executed. It increments automatically. But during a go to or call instruction, it jumps to a new address. During interrupt, the program counter value is pushed to stack and restored later. And then next, memory organization. There are 3 types of memory. Flash memory, which stores the program. RAM is a temporary data storage. Third is a EEPROM. It stores a permanent data even after the power is removed. RAM is divided into banks, which is important in C programming. And then I/O port. We are having a totally 33 I/O pins configured in a 5 ports. Port A, Port B, Port C, Port D, and Port E. Port E, the tri-state register is a data direction register. Some pins can also act as an analog input for ADC modules. Next, move on to timer modules. It contains 3 timers. Timer 0, 1, 2, 1 and 2. Timer 0 is a 8-bit. 1 is a 16-bit, and timer 2 supports PWM operation. It also 8-bit. Timers are mainly used for a delay generation, event counting, and interrupt generation. Moving on to ADC module. It's an analog to digital converter. It's a 13-bit ADC module with 8 channels. It converts analog signal into digital value. This is very useful when interfacing sensors like a temperature sensors, soil moisture sensors, and light sensors. Moving on to CCP module. CCP is nothing but a compare, capture, and PWM. It's mainly used for generating a pulse with modulation signals. These signals are used in motor speed control, LED dimming, and servo control. Next, move on to serial communication. It supports a multiple communication protocol like a USART, SBI, I2C. USART is used for serial communication with computer. SBI and I2C used for a communication between the embedded devices. It's a very important in industrial automation. Next, interrupt. Interrupt or allow the controller to respond immediately to event. PIC support external interrupt, timer interrupt, ADC interrupt and communication interrupt. When an interrupt occurs, execution jump to special interrupt service routine and then return back. Moving on to power management unit. It includes a power saving features like a sleep mode, watchdog timer, power on reset, brownout reset, and it reduces the power consumption. Watchdog timer reset the system if the program hangs. This improves reliability in real-time application. Moving on to application part. It is used in smart irrigation system, home automation, motor speed control, traffic light controllers, temperature monitoring and industrial automation. Because of its simplicity, flexibility, we are widely using in education and real world projects, or we are using a PIC16F877A in very wide manner. Coming to conclusion, understanding this coming to conclusion, this is a mind map for the PIC16F877A. These are the reference resources. Understanding this architecture help you in programming, projects and exams. If you find this video is very helpful, don't forget to like, share and subscribe. Thank you.